Welcome to Algo Guru. In this video, we are going to talk about some of the very common problem solving techniques. I'm not going to cover a lot of them. I'm just going to cover some of the very common and most importantly at a very high level. So you might well have to look at other resources going forward in order to learn a lot more. But here I'm going to talk about some of the very common ones. So let's start with sorting. In some of the problems, sorting the input, if you have an input array and if you are going to sort it, it's going to make life a lot easier and you can come up with an optimum solution pretty fast. But for example, let's take a problem like find the maximum subarray. You are given an array of integers and you have to find a subarray which has a particular value or a particular sum in it. If you're going to sort the array, it's going to screw up everything. So there's no way of sorting it. You have to do it by a big O of n solution. And you can do that using sliding window or any other approach that you can come up with. But there are a lot of common problems, like, for example, like in meeting rooms or activity selection or merging intervals. There's a lot of problems out there, especially related to greedy, where if you sort the input, it is going to make the life a lot easier when it comes to coming up with a optimum solution. And remember that any sorting using whatever the platform provides you in C++ or for that matter in any other programming language, it will take like a big O of n log n. And that is a time complexity that you need to be really aware of. And the next one is searching. There are two types of searching, linear search and binary search. Linear search is a big O of n complexity and it comes up very rarely. This is like something like a beginner level. Whereas binary search, which is a log n time complexity, comes up a lot because there are a lot of problems that you can solve with binary search. So it's very important that you know what binary search is. We may cover some problems using binary search, but I'm definitely not going into tell like what exactly is binary search or something like that because that's very trivial and that's very basic stuff. The next one is recursion. Recursion comes up a lot of problems. If you look at backtracking, you look at divide and conquer, dynamic programming, a lot of these places, recursion or recursive solutions are a very common pattern. It's a very complex thing and it has to be coded very properly. And I've given an example here. Like you have a function and it takes an input string. And the first time you call it with A, B, C, D, E. And every other call, you are going to pass a substring. And finally, the last call, you're passing an empty string, and that's exit conditions. Very important that recursive uh, functions have an exit condition, or else it's going to go into an infinite loop. And another very important thing to remember is that recursion uses a lot of stack. But it's very important to learn recursion and it's very important to optimize it in such a way that you can write a solution in just a few lines of code. What you can write in 5 lines of recursive code, it may take several more in an iterative solution. So these are the high level three things that I wanted to talk. And finally, just jump into the complexity analysis. As you might already know by this, that there are time and space complexity, and both are given in terms of big O of something. It's the worst case scenario, and a linear search is an big O of n, and binary search is O of log n. So it's very important that you get a really good understanding of time and space complexity. You have to get it right, and you have to get it right all the time. So I think this covers all the introduction stuff, and starting from the next videos, we will start getting into the real meat of the stuff and start solving problems. Thank you.